We're going to talk about squares and square roots. So please make sure you write your first and last name at the top, today's date, and very important, the period number you're in. Okay, because it's early in the school year, I want to make sure that you get credit and I'm able to load your score as soon as possible, okay? For the situation, we have two students. Two students found the area of parallelograms. Use their work at the right to answer A and B. Which student found the area of a square? Explain. Okay, so was it Brad or was it Collins? So what I like to do is always sketch out a visual of what it looks like. So we have a parallelogram right here. To find the area of a parallelogram, we have to take the height times the base. And over here we have the height multiplied by the base. Okay, which student found the area of a square? Remember that a square means a number, any number, times itself. So this student, Brad, took 2.5, the height, times the base, which was 6. Is that a number multiplied by itself? Nope, that's a number multiplied by a different number, so he didn't get a square. But Collins took the height of this parallelogram, which is 8, and he multiplied it by the base, which is also 8. 8 times itself gave him the area. So we could put Collins as our answer. Collins found the area of a square because he multiplied 8 centimeters by itself. For B, in what other way could the formula for finding the area of a square be written? We could say that it is x squared, or area equals x squared, or we could say the area equals one side squared, side times side, or side times itself. So we could write this a number of different ways here, but just know that we're taking one number multiplied by itself. Moving on, squaring a number is the same as multiplying the number by itself, or raising the number to a power of 2. For example, 4 squared equals 16, because 4 times 4 equals 16. Be careful to note negative signs and parentheses when squaring values. Observe the difference below. Okay, very important here, we got to make sure that we understand what is the base and what's the exponent. By base, I mean what number is being multiplied by itself. The base right here is everything inside the parentheses. Okay, so what's inside the parentheses? Negative 2. We got to take that base, multiply it by itself. Negative 2 times itself. Negative 2 times negative 2 is going to give us a positive answer. It gives us positive 4. But now on the next one, ask yourself, what's the base here? What's being multiplied by itself? Is it negative 2 or is it positive 2? The base itself is just 2. In this case, okay, it's positive 2 times itself, and that gives us 4. And now, according to order of operations, we do the exponent first, and then we add in the negative sign. Technically, this is 2 times itself multiplied by negative 1. We just don't write the negative 1. More on that later, but the base here is 2 multiplied by itself, which gives us 4, and then we attach the negative. So what is the base right here? This is everything inside the parentheses. Negative 3 times itself, negative 3 times negative 3 gives us a positive. That gives us positive 9. And now, what is the base right here? What's being multiplied by itself? Just 3, not the negative, just 3. So 3 times 3 gives us 9. Now afterwards, we are going to attach the negative. 9 times negative 1, or 9 attaching a negative sign to it, gives us negative 9. Well, the square root of 16 is both positive and negative. Okay. We could say that it's 4 and it's negative 4 because 4 squared equals 16 and the quantity negative 4 squared, negative 4 times negative 4 also gives us 16. The positive square root is known as the principal square root. Okay. So sometimes you have situations where the positive number times itself gives you a square, and also the negative number times itself gives you the same answer. But the positive square root is called the principal square root. Any number with a square root that is a whole number is called a perfect square. So let's look at some perfect squares below. Complete a helpful reference for the first 15 perfect squares and square roots by filling out the tables below. So looking at this more closely, let me fold this in half. 1 times itself, 1 times 1 gives us 1. 2 times itself gives us 4. 3 times itself, 3 times 3 gives us 9. Okay, and so on. Moving down below, we can say that the square root of what number was 1? Or in other words, 1 times itself gives us 1. 2 times itself gives us 4. 3 times itself gives us 9, and so on. So you notice that our numbers up here for our perfect squares are the same as our numbers down below. Going over to the reverse side here. Evaluate the following squares and square roots. So let's look more closely here. The quantity, okay, everything inside the parentheses is being multiplied by itself. So negative 7 times itself, negative 7 times negative 7 is going to give us a positive 49. Okay, what's inside the parentheses here? 2 over 3 times 2 over 3. So 2/3 times itself will give us, so in this case we can't reduce it. We can't reduce either one, so we're just going to multiply straight across. 2 times 2 up top in the numerator gives us 4. 3 times 3 down below in the denominator gives us 9. So 4 over 9. And lastly, here we go again. Okay, what is the base? What's being multiplied by itself? It's just 9. 9 times 9. 9 times itself gives us 81. So we're done with the exponent, but now we have to add in the negative. Or we technically multiply negative 1 times 81, which gives us negative 81. So if there's any questions about the rules of negative exponents, please ask me during class at any time. And let's do a few more together. Apply your knowledge of square roots to evaluate each expression. Here we have the square root of 64. So according to order of operations, we have to do our exponents first before we multiply anything. And let's do our square root first. What is the square root of 64? What number times itself gives us 64? And if you filled out the chart earlier, you might have 8 already as your answer. So 8 is the square root of 64. Now we have to multiply that number times 2. 2 times 8 gives us 16. Now, let's take the square root of 121. What number times itself gives us 121? That is 11. And now we have 11 plus 5. 11 plus 5 gives us, again, 16. And finally right here, what number times itself gives us 225? And you might have calculated 15, which is correct. Yeah, 15 times -3 plus 10. So according to our order of operations, what comes next? Do we multiply or do we add? So we are going to multiply first. -3 times +15 gives us -45. -45 plus +10 will give us -35. So if there's any confusion about the rules of positive and negative numbers, we're going to be going over that several times in the coming week. Thank you.